Hello and welcome to today's webcast brought to you by FDIC. Today's event, Standpipe Operations Part 1, System Orientation, will be presented by Bill Gustin, Captain of the Miami-Dade Fire Rescue Department, and sponsored by Key Hose. This presentation is both live and interactive, so you can ask questions at any time by clicking in the Ask a Question box in the presentation window. If you are running pop-up blocking software, you will need to disable it to view this webcast. In addition, it is recommended that you close down all other applications for better performance. For your convenience, this presentation will be available on demand within 24 hours of this live event. A reminder email message will be sent to all registrants with a link to the archive. It will also be accessible from our homepage at fdic.com. Now it gives me great pleasure to introduce Captain Bill Gustin. Bill is a 41-year veteran of the fire service and a captain with the Miami-Dade Fire Rescue Department in Florida. He began his fire service career in the Chicago area and conducts firefighter training programs in the United States, Canada, and the Caribbean. He is a lead instructor in his department's officer training program, is a Marine firefighting instructor, and has conducted forcible entry training for local and federal law enforcement agencies. He is an editorial advisory board member for Fire Engineering and FDIC. He was keynote speaker for FDIC 2011. Ladies and gentlemen, Bill Gustin.
Good afternoon, everybody. This is the oldest man in the room, Bill Gustin. Before we begin, I want to give a few shout-outs. One is to Key Hose. I thank them for sponsoring this webcast. I also am a big believer in Key Hose. We're talking Standpipe Operations this afternoon, and you are going to have a hose that has a good mix of durability, flow capability, and weight, but you do not want to substitute durability for strictly weight. So I can't think of a better hose to use for standpipe operations than Key. You definitely are going to need a hose that has incredible kink resistance, and the Key Combat Ready is the perfect hose for standpipe operations. Secondly, I want to give a shout out to our brothers and sisters on the London Fire Brigade and our brothers and sisters in Hawaii, both of which within the last month, in the case of Hawaii, the last week have taken a terrific beating and have opened everybody's eyes. When I mean everybody, not just the fire service, I mean the public in general. We now know how quickly a high-rise fire can get out of hand, especially if they are not equipped with sprinklers. So I think you're going to see, if there's anything good that comes out of tragedy, it's that things get done in terms of precautions, and hopefully this will be the incentive to get the buildings that are not equipped with sprinklers equipped with sprinklers. But having said that, any firefighter that says, oh, don't worry about that building, it's sprinklered, we'll never have a serious fire in it, has never had a serious fire in a sprinklered building. I have a friend of mine that has made 2 grabs in 2 consecutive years. One was a fatal fire in fully sprinklered buildings. In one case, it was a large condominium. The only sprinkler head in the room of origin was a sidewall, and it was covered up by a large armoire cabinet. So the fire did not extend beyond the room of origin, but you know the amount of smoke that would be generated with today's plastics in just one room of fire. So don't think for a minute that sprinklers will completely eliminate the problem or eliminate the life hazard of a high-rise fire. Let me get to the next slide here. Okay, there's a young Bill Gustin. I started in the fire service in 1973 on the Wheaton Fire Department, 20 miles west of Chicago. And I spent 3 years there and 2 years as a paid fireman in Naperville, Illinois, also in the Chicago suburbs. And for the last 39 years, I've been with the Miami-Dade Fire Department, and that last patch is our mascot, the Joker. I'm captain of Engine 2, and I'll be hanging it up pretty soon. I'm 62, but I still have a passion for the job. Just recently, this was last summer, I believe, We had a gas explosion. This was a very significant event for our department. I have a very diverse jurisdiction. We go from everywhere from tomato fields out near the beginning of the Florida Keys to dense high-rise concentration along the Atlantic Ocean and the intercoastal waterway. So it's a very interesting place to work. In this particular case, you had some guys installing a boiler up on the rooftop. There was a gas leak, and the resulting explosion blew the side of the building out. Nice panoramic view of the Atlantic Ocean. This could have been a holocaust. It rained down chunks of concrete on people on the beach and through the roof of a little two-story mom-and-pop hotel that was adjacent to this high-rise that at the time was not occupied except by construction workers. When we think about high-rise buildings and buildings equipped with standpipes, there's two general categories. One is commercial. That would be your offices. And we'll talk more about that in our next section. Today we're going to concentrate mostly on systems, but this is just an introduction. So we have commercial high-rises, which are your office buildings, and then we have residential. And when we're considering a residential building, you have to consider a resident like this fellow right here in his motorized wheelchair. When the alarm goes off and you get a pre-recorded message telling him not to use the elevators, to use the stairwells and evacuate, how comforting do you think it is to him? Well, it's not comforting. He's not going anywhere. So in these kinds of buildings, our strategy for the most part will be protect in place. Most of us are on departments that do not have the resources in terms of personnel to effect a timely evacuation, nor are the buildings designed to be completely evacuated in a timely fashion. As a fire officer, we have a decision to make. Do we take the people away from the harm, in other words, evacuate, or would we be better off protecting in place and taking the harm away from the people by putting water on the fire, controlling the fire, confining the fire, and hopefully the compartmentation of the residential building will keep these people, except the ones in the immediate fire area, in relative safety. When I say relative safety, I mean no one's safe. But would they be safer off staying in their apartment or condo rather than venturing out into a smoky hallway or trying to climb downstairs that are full of smoke? So that's a decision that we're going to have to make. But in many cases, the best thing is get water on the fire. That will protect the most people. So strategically, our objective is to protect life. Tactically, the way we achieve that strategy is by putting water on the fire, and in this case, knowing how to operate from a standpipe. Everything we do is in accordance with an ongoing size-up that recognizes the risk versus the benefit. In this situation, when we're operating in an occupied high-rise building, be it a commercial or a residential, our risk is going to be great because our reward, our perceived reward, is great. Our objective is not to protect property. That's not our primary objective. Putting water on the fire is to protect life, the life of people like this little old lady right here that cannot get out of this building on her own power. So, when we are ascending into a building equipped with a standpipe, be it a commercial or a residential, and it is impossible or impractical to evacuate everybody from this building, as we are climbing the stairs and connecting our hose line and stretching it down the hallway from the stairway, we are on every bit as much a life-saving mission as we would be if we were dragging an unconscious person down a smoky hallway. It's that important. Protect in place. Now, having said that, what have we learned within the last month? It's pretty hard to protect in place when you have fire scaling the outside of your building being fueled by combustible cladding, that is, polyethylene sheets of plastic sandwiched in between two very thin layers of aluminum. That's going to be a problem. It's a problem for the United States, but it seems like it's even a bigger problem in other parts of this world. So we're going to have to rethink some of that. Also, post 911. Not all your residents, not all your occupants are going to listen to the directions of the fire department given over the voice command system of the fire alarm panel. They are not going to necessarily obey the orders or the suggestion to stay in place. So you're going to have competition in the stairwell, whether you want it or not. This is why it's so vital for us to direct these people to the proper stairwell, because once we open that stairwell door, we could be turning that stairwell into a chimney, and everybody above the level of that fire is in danger. Now, there's a big city in the Midwest of the United States that had a bad experience with that, and they totally revamped their high-rise procedure to recognize the fact that they are not going to open that stairway door until they make sure that they have evacuated the occupants that would be above the level of the fire in that stairway. Additionally, I'm coming to you today from Tampa, Florida, and I operate in the Miami area. We have reverse stack effect to consider, whereas today, it is much, much cooler inside of an air-conditioned high-rise building than it is on the outside. Therefore, if you have a fire at the upper levels above the neutral pressure plane in an air-conditioned and sprinklered high-rise building, the tendency is for the warm, humid air at upper levels to enter the building to be rapidly cooled off and then sink like a brick coming down the elevator and stair shafts. So it's not just the people that are above the fire, it could be below the fire as well. So is there a risk? Yes, there's a risk taking elevators. Sure, there's a risk. But remember, it's worth the risk, because we're not there just to save property. We're there to save lives, and the best way for us to protect the lives and the greatest amount of lives is put water on the fire in many cases. There's 4 things that it's going to take for us to be successful in high-rise firefighting, and the first is pre-fire planning. I like to, when I teach my department at slower battalions, I'm in a fairly active battalion, and we do a fair amount of firefighting, but I'm going to be quite honest and tell you that most of the fires we fight are room and contents in relatively small buildings. So we could go to dozens and dozens and dozens of those types of fires. Dangerous fires, challenging fires, but they don't make us any more qualified or prepared to fight a serious fire on the 18th floor of an office building or a condominium. No one, I don't care if you're in Midtown Manhattan, is doing the amount of high-rise firefighting necessary to derive enough skill and knowledge strictly from your own fire experience. You're going to have to drill extensively, and you're going to have to know the buildings, and we're going to spend a lot of time today on systems. And systems is a major aspect of pre-fire planning. When you look at a hallway that's several hundred feet between stairwells, you better know before you go. Now, there's 2 ways that we gather information. One is during our pre-fire planning, learning as much as we can about the building before we ever have an alarm. And then once we do receive a report of a fire or an automatic fire alarm, we still have to know certain things before we go. Before we leave that lobby, we definitely need to check the annunciator panel and find out where is the alarm initiation, if ever, if any. And what kind? Is it a pull station, smoke detector in an elevator lobby? Is it a water flow? And also, we're going to have to scroll back in the alarm panel to see if there's any previous initiations before we got there. Now, I was fooled this way. I arrived at a automatic fire alarm last summer and looked at the panel, and it says a pull station, 13th floor. Had I scrolled back, I would have saw with about 6 minutes before that, water flow, 14th floor. and I didn't look at it, and then here comes Niagara Falls coming down the elevator shaft before I got in it. So remember to scroll back. You need to know where the fire is. You need to know the layout of your stairways, which is not always apparent from the first floor lobby. You need to know, does the elevator reach the fire floor? Could it possibly reach the fire floor? Could there be a different bank of elevators that you could take that would be safer, that would deliver you to a different part, a different wing of the building? So these are the things that you need to know, and the best way to find them out is during pre-fire planning. An office that you could have a floor area as big as almost a football field. You better know before you go. And that also means you have to know where the fire is. You have to have a general idea where the fire is. Now, can we triangulate? Can we look at an alarm panel? Can we compare it against a floor plan? Can we get a general idea of where is the closest attack stairwell? And then the closest attack stairwell may not be appropriate if it's a smoke tower, because it can create an area of low pressure and draw the smoke right to you. The best time to make those decisions, brothers and sisters, is during pre-fire planning. And the systems. We're going to harp on systems today. Now, they might not be as interesting as dragging a hose line and fighting a fire in an apartment or a condominium or office. But in order for us to operate as professionals, whether we are volunteers or paid career firefighters, in order for us to operate as professionals, we have to be able to control the systems in these buildings. In order to control a fire in a high-rise building, we have to be able to control its systems, which means we have to know the systems. Something as simple as this. Older buildings, I'm talking pre-1970s for the most, may have a separate automatic sprinkler and standpipe system. Newer buildings, as we will see, typically have a combination system where the branch piping on each floor for the sprinklers is branched off of a 6-inch standpipe, usually running in the stairwells. And we'll talk more about that later. That's a color coding that I believe the FDNY follows. Sprinklers are green, standpipes are red. I can't speak directly to the FDNY because I'm not on their department, but I do believe, and I could be wrong, and I'm sure I will hear from one of our participants, that their policy is to pump the standpipe first and then pump the sprinkler second. To me, it seems like a moot point. I mean, you put one line into inlet at first and pressurize them both. Now, it's 3 o'clock in the morning. You got an automatic fire alarm. You go up to the 13th floor. You take a walk up to the 14th from the elevator lobby. And you stand there with a water flow on the 14th, and you're scratching your head looking at that. Now, that's not a good position to be in. If you're not familiar with that configuration there, that can be daunting. That can be intimidating. So how are we going to learn these systems? We walk into a fire pump room. It is intimidating because we're not, in my opinion, as firefighters, not fire prevention, not fire suppression contractors. I'm talking about your average brother or sister that's riding a fire engine or fire apparatus and responding to medical calls and a few fires now and then. We have not been adequately trained, in my humble opinion, on systems. And we have to be able to control the systems. Where do we learn systems? Well, we're not going to learn them from ranks of firefighters. It became apparent to me as I started walking through buildings under construction in my district how ignorant I truly was about the configuration and the function of fire detection and suppression systems. So who did I reach out to? I reached out to people that work with these systems every day. That would be our fire prevention people and fire detection and suppression contractors. To me, there is a huge disconnect between fire suppression personnel, the macho firefighter that rides the fire apparatus, and the professionals in the fire prevention and fire suppression system industry. And shame on us as fire suppression personnel if we do not reach out to these professionals to learn these systems. We can't do it on our own. We've got to stop this disconnect. Now, this is a schematic of a pump test that took place on a 56-story building on the Atlantic Ocean. And I'm not speaking specifically of this drawing. That's not important. But as a firefighter, we should be able to look at that and make some kind of sense out of it. And this is when we learn a lot about a building, brothers and sisters, before it gets its certificate of occupancy. It depends upon the jurisdiction, but in my jurisdiction, we pretty much own that building before it gets a certificate of occupancy and the tenants start moving in. That's the time to participate in flow tests for testing these systems. Let me back up a second. This is what I like to do. You get a 56-story building on in my case, it would be the Atlantic Ocean. And the fire suppression contractor says, okay, well, I've got pumps here. We've got 3 zones here. I've got the high zone and the medium zone or mid zone is on the ground floor, and then we have on the 40th floor we've got a pump for the high zone and some elevated tanks. Okay, well that's great. I see all your pumps. Now what I want you to do, sir, is I want you to shut all those pumps down, and we're going to pump to the roof through the fire department connection. And usually you'll get some kind of pushback from that. What? Why would you want to do that? Do you know how much pressure you're going to have to pump into that FDC to get that water to the roof? Yes, I do know, sir. Well, why would you do that? Well, is there a money-back guarantee that those pumps are going to function every time in every situation? The answer is there's no guarantee on anything in life. So it is, and it's something that we use that opportunity not only to familiarize ourselves, but it's a great drill, a great training opportunity, and a unique opportunity, because we're never going to get a chance to do that again unless we have a real fire. This is a fellow that I've learned a lot from. This is Kevin Carrier. He's become my dear friend. He's not a firefighter, but he hung sprinkler piping and installed fire pumps for 33 years. The man knows his business. I don't think a shift goes by when I'm on duty that I'm not picking up the phone and asking Kevin a question about fire suppression systems. Day before yesterday, I called him up and asked him about dry pendant sprinkler heads. So I'm constantly bugging this guy. I'm in his hair all the time asking him questions. I've picked his brain. In fact, I probably picked it clean. You talk about some heads-up pre-fire planning. This is a form, a chart that is laminated and is put on the apparatus, inside of the apparatus compartment door in Clark County, Nevada. Now, Clark County, Nevada has responsibility for the majority of the large casino and high-rise hotels on the Las Vegas Strip. So what they have done is they have ascertained what is the demand pressure for the sprinkler systems in these buildings. Now, notice something here. How did they arrive at these pressures? Through flow tests. Now, did they conduct every one of the flow tests? No. But your authority having jurisdiction, and NFPA 14 requires fire suppression systems to be tested at a periodic time, some of them on a yearly basis. Fire pumps should be tested on a yearly basis. There's a specification plate on a fire pump that may indicate the churn pressure, the highest pressure that the pump can achieve without flowing any water. That would be an indication. Your previous fire pump tests examine the churn pressure. That may give you an idea. Now notice something else. It doesn't say what floor the fire is on. In other words, you take a look at Caesar's Palace. It says 280 psi. What if the fire's on the 15th floor? Well, guess what? When we get into pressure-reducing valves, we're going to find out that the building's fire pumps don't know what floor the fire is on. The building's fire pumps don't count the number of floors, multiply by 6, and then add 100. They don't know. The building's fire pumps only know the pressure necessary to get 500 gallons a minute to the roof in the primary standpipe outlet at 100 pounds residual pressure. That's the pressure necessary for overcoming the friction loss and to achieve an adequate nozzle pressure, 100 pounds residual, and 250 gallons per minute for any additional standpipe. Unless you have a huge, huge office building, in that case, it has to be 500 gallons a minute for every standpipe. Again, it doesn't matter where the fire is in the building. We'll go into more of that in a minute. All right. So, pre-fire planning is absolutely essential. I mean, do you know the demand pressures for the high zone at this particular building on this hotel on the Atlantic Ocean? Well, if there's not a sign, let's make sure there is a sign. And how is that? Well, we're going to do pre-fire planning. We're going to spend a lot of time on the street. The companies in a high-rise district, you don't go to a lot of high-rise fires. You go to a lot of automatic fire alarms, but thankfully we're not going to a lot of high-rise fires. So in the time that we're not responding on fire alarms and fires, we're spending a tremendous amount of time training in standpipe evolutions until the functions are almost nonverbal amongst our firefighters, and knowing the location and the demand pressures of our fire department connections. So when we're looking at a building here like this, we see in this case, this is interesting. There's two in the foreground. There's one electric motor driven fire pump, and then in the background, there's where the firefighter is. There's two. The one pump supplies the low system, which I believe is the ground floor to about 25 or 28 floors. It also pumps into the second pump in series, and that second pump then doubles the pressure and runs the water at a much higher pressure through an express riser. That means a riser that has no outlets on it from all the way in the stairwell. There's two risers in the low zone, and you wouldn't see any outlets on the high side riser until you got up into, let's say, the 28th or 29th floor. So, pre-fire planning. It has to do with knowing the demand pressures of your fire department connections. It has to know the location of your fire department connections. And 3 o'clock in the morning is not a time to be looking for them. And landscaping is not our friend, brothers and sisters. PIVs, fire department connections, are a lot of times covered with shrubbery because out of sight, out of mind as far as the building owners are concerned. Okay, so pre-fire planning is our first ingredient for success when operating in standpipes. Number 2 is training. Now, I picked this picture particularly because it is indeed a parking garage. I would rather train in a parking garage rather than a training tower any day, anytime, any day. Why? Most training towers do not have a hallway, therefore they do not replicate the conditions that we are going to find in a real building, whether it's commercial or it's residential. In a training tower, firefighters get accustomed to stretching 3 lengths of hose, one on the floor below, one on the stairway, and one right at the fire floor. Bam, and you're there. You open up the stairway door, operate the line. Man, that's great. That gives firefighters a false sense of accomplishment and capability. Training towers typically don't have hallways. You can simulate hallways in a parking garage, and since most of them are concrete, at least in my portion of the world, we can flow all the water we want. We also have an opportunity with our public housing authority to actually run full-scale drills in one of our, it's a project building. It's for elderly folks. And the folks at the county housing department are cooperative enough, and they realize that it benefits them as well. And we run some pretty tough full-scale drills. And if you'll notice, we got a lot of people on that 2.5-inch line. I'm telling you, one of the biggest mistakes, one of the biggest miscalculations that a fire officer can make is to underestimate how many people it takes to move a 2.5-inch hose line down a hallway, particularly if it has to turn corners. And it's not just that first team that starts to advance that hose line. How long will it be before they tire? I think we've all seen the conditions inside the hallway of that building that was in Honolulu. Can you imagine the beating that those firefighters take, or they did take in that building? Can you imagine that, I don't care what kind of shape you're in, especially if you had to take the stairs, just the heat alone would drive you to the floor. You would be out of air so quickly. So it's not just a matter of how many personnel you have on the hose line and where they are strategically placed to keep it moving around corners and friction points, but do you have another team on the bench, so to speak, ready to relieve that team when they become physically exhausted and expend their air supply? And then what? Who's going to relieve that team? Well, let's say you don't have enough people. What happens? Have you made matters worse or better? You may have made matters worse. Why? You've abandoned the hose line. Everybody's out of air, or they're exhausted. The hose line is propping open the stairwell door and filling the stairway full of smoke. Have you made things better or worse? You may have made things worse. So, about once a year, we'll go ahead and we'll run this full-scale drill. And then when we get finished, we have to get in there with mops and buckets. And actually, we've had to paint before. We have to repair all the marks and bruises we put in the wall. There's nothing delicate about staking a 2.5-inch hose line, several hundred feet of it down a hallway, and through an elevator lobby and into an apartment. I picked this slide because it has a battalion chief. I am very lucky on my department that we've got the 12 operating battalions, and that in a high-rise fire with a standpipe operation, we would have at least one battalion chief up on that scene. Brothers and sisters, as soon as a company officer puts a hose line in their hands, their field of vision and their ability to conduct a multi-company operation is diminished greatly. You can't run a multi-company operation if you're physically involved in the task. Well, you say, well, I don't have enough people on my department. I'm telling you, brothers and sisters, the fire doesn't care about your staffing. If you have a fire in a high-rise building, whether it's in downtown Chicago or it's in your town, it's a fire is a fire. It doesn't care about your staffing. You better get the staffing. Well, how do you get the staffing if you're on a small department? You drill with neighboring departments and you work together to develop a regional high-rise plan, because most fire departments in this United States cannot handle a major high-rise fire by themselves. Now, what do I mean by a major high-rise fire? You got a nasty, smoky fire that's auto-exposing floors above and filling stairways and hallways with smoke, and you have people that can't get out of that building. You've got a major high-rise fire on your hands, and you better be calling for the cavalry right away. So, part of training is not just developing the skill levels, but it's also understanding the critical need for how many people it really takes to get that hose line moving and keep it moving until it's operating on the fire. Everybody wants to be on the nozzle, but if everybody's on the nozzle's never going to get past that first stair landing. How do you strategically place your people? We'll talk more about that in our next session on evolutions. But for the most part, use a parking garage. I would rather do that than a training tower. Space your people out on the line and practice until it is nonverbal. When you hear guys yelling for more hose in their mask and over the radio, you know that evolution is heading south. All right, the third thing is equipment. What are you taking with you? You can't run back to the rig if you forgot something. So we're going to talk about hose, forcible entry tools, accessories, and the contents of an accessory bag. We'll get into that. Now, this is an idea. I just want to throw this in here. This is something I learned from a fire officer from Ottawa, Canada. The gentleman's name is Mr. Pete McBride, a fine gentleman. And he posed a question to a group of fire officers and said, well, you know, it's all well and good to drop a fire blanket over the windward side window of a wind-driven fire when there's a wind-driven fire, but what about if you lowered a Bresnan distributor? And, you know, it's when it's not your idea, because of our big firefighter egos, when it's not your idea, your immediate reaction is say, that would never work. Well, roll this video and you tell me that it wouldn't work. The Bresnan Wind. Roll the Bresnan Wind video. Okay. Hey, give it a try. Go to a parking garage. Go to a training tower and try it out. Okay. The next requirement is physical fitness. And I don't care how good a shape you are. You are only as physically capable as the weakest guy on your crew. And nothing will wear a crew out faster than having to take 20, 30, 40 flights of stairs. And that's why taking an elevator is a calculated risk. Should we use a standpipe? Not necessarily. You got a building with an exterior hallway. This type of building, which is very common in the Sun Belt. With that kind of building, quickest way to get a hose line up there is not to connect to a standpipe. It's to drop a rope out of a window from a balcony. Do you have a well? If you have a well, you could one 50-foot section of hose can ascend up to the fifth floor. Would we ever use the hose cabinet in the tenant space in the hallway? Never say never. Never say never. What about a healthcare facility? You've got a smoky fire in a linen room in a nursing home. If you stretch from the outside and you go through a couple of smoke barrier doors, haven't you contaminated a much greater area? Is there a risk in using the hose cabinet in the tenant space? Yes, of course there is. I realize that. But again, everything is risk versus benefit. If we can confine the smoke to a limited area by using a hose line from a cabinet in the tenant space in between the two smoke barrier doors, I don't say do it. I say consider it. Also, you've got an out-of-control fire auto-exposing several floors. You've got truck company firefighters. If they're checking for extension on upper floors, if they've got hose cabinets, chances are they're going to use them. If they don't have any hose with them, what else are they going to use? So never say never. Ideally, brothers and sisters, we would not use the hose cabinet. And what is the reason? The reason is you run out of air or have problems with your mask, you try to follow that hose line back. Where does it take you? It doesn't take you to a stairwell. It doesn't take you to a means of escape. It takes you back to a cabinet. And then can you find your way out? Can you find the stairway? So don't ever say never. Consider there could be an opportunity for you to use hose in a cabinet in a tenant space, and the time to determine that is during pre-fire planning. Now, how does the water get into the system? If we're looking at the flow of water here from left to right. I'm looking first at a post indicator valve, and that is the valve shutting off the municipal water supply that is then coming up into you see the first OS and Y, outside screw and yoke valve, and then you see a double backflow detector check, and another OS and Y. Now, what that is for is let's say you have a 30-story building, and the city should lose its pressure. That means that nasty water that's in the standpipe would end up coming down with head pressure and had the possibility of polluting the city's potable water supply. So now in Florida, in my part of the world, the backflow preventer is outside the building most of the time because we do not have freezing weather. In the northern climates, that detector check valve would be located, or an alarm check valve, which also can act as a backflow preventer, would be in a heated space. And then from there, we see a fire department connection to the right. Now, we could shut off those OS and Ys. We could take that backflow preventer out and take it to the shop to repair. We could shut off the water supply from the city at the PIV. We would still have water to the system. Why? Because we would pump the fire department connection, which is downstream of those flow preventers. Does the building have tanks at mid-level or from the roof? Many do. This is a tank in our jurisdiction that does, and then at roof level they have pumps that actually pump the water down to the standpipe outlets in the high zone. Now, this is water coming into a split case, a horizontal shaft fire pump. On the left, you see the intake pressure from the city, and on the right, you see the pressure from the pump is generating. And if you subtract the pump discharge pressure from the city pressure, you get what's called a net pressure. A net pressure, that's the pump the pressure that the pump is actually generating, not just adding onto the city pressure. There's another pressure that's called churn pressure, and that means that's when the pump is not really flowing any water other than hopefully just from some type of relief valve. That would be the highest pressure that the pump would attain. Here we're getting a city pressure there of about 60 and a pump pressure of about 240 pump discharge pressure. Okay, these are a couple of electric pumps again, and as you see, the vertical metallic-looking devices on each side are the jockey pumps that maintain a constant pressure in the system. Now, at a certain point, if a sprinkler head was to activate or a standpipe outlet was open, that would overwhelm the ability of the jockey pump to keep the system up, and then the fire pump controller would kick on the fire pump. This is a diesel-operated pump. There's three ways of power, two common ways, diesel and electric. The electric typically have a backup generator that could transfer the power to the electric motor if the building's power should fail, and then it kicks in an emergency generator. This is the brains of the fire pump. It's a controller. Basically what it does is it senses a drop in pressure. Now, this is old school, what you're looking at right there. It's almost like a mercury switch. It's like a pharmacist scale, and when the pressure drops to a certain point, that mercury switch tips, completes a circuit, and in this case, starts a diesel engine. Okay, so let's take a look at a little bit of the schematic here of this building. And in this case, you can see that you have a high zone and a low zone. Again, I don't want you to focus just on that. I want you to get an idea that you need to make this your business. You need to make it in if this building is in your district, you need to see these plans. After the building is built, while the building is being built, avail yourself to these plans. It's part of your business. It's not just the fire department's business. Look at here. The engineer of record agreed to perform a test that the filling line to the storage tank can be used to supply the high zone standpipe system. NFPA 14, 2007 edition, requires the standpipe system demand be supplied through the fire department connection. The system shall be tested at the 32nd floor and at the riser level discharge of each valve, not to exceed 175 psi. Those are the types of requirements that you're dealing with. And this is where we're going to get into pressure reducing valves. This is a pump test. They're testing the pumps for the parking garage, and that's the diffuser, and that's connected up to a remote pitot gauge, and then from there they read the gallons per minute flow. They're up on the roof. This is a 2 standpipe system, 2 stairwells, so they would have to flow a total of 750 gallons a minute. That's 500 gallons on one standpipe and 250 on the other at 100 pounds PSI residual. Now, okay, we had our fire. The building is sprinklered. The sprinklers are flowing. Where do we shut them off? You don't shut them off there. You definitely do not shut them down at the street. Do not shut down the intake side of a fire pump. Also consider this. Let's say you got a gas leak in an oven in a 400-unit apartment building. Would you go and shut off the gas to the entire building? No, you would go to the closest to the source of the leak, and that's where you would shut it off. You're not going to shut it off here, too. What happens if you shut off that water right there at that PIV or at those OS and Ys? Have you shut the fire pump down? Oh, you haven't. Well, then you just burned up a $12,000 fire pump and maybe a $20,000 diesel engine. The fire pump needs water to keep itself cool the same way that we crack a discharge or crack a tank fill on our fire pumps. When we walk into a fire pump room, we want to know, is the fire pump working? Is it going to continue to run? If it is flowing little to no water, you should have a relief valve that is flowing some water. Additionally, you should see you should check the packing. I'm getting ahead of myself. I want to show you something else here. This is a Cummins diesel engine that's running a fire pump. Do you see any radiator on that engine? No, you don't. No, you don't. A diesel engine that drives a fire pump requires a continuous flow of water. If you don't see that, that engine is going to burn up. It's going to burn up, and in short order. Another reason why we do not shut off the water supply to the fire pump. When you go into the pump room, is the diesel engine being cooled? Forget the control valves at the base of the standpipe. That's another, leave those valves alone. That's what we're shooting for, people. We want to go to the specific floor, into the stairway, and locate the zone control valve. What I'm reading a question here. Should he not go to the area of refuge in the stairwell on his floor? Hey, I'm going to answer that question right now. The answer to that question is yes and no. Our newer buildings have an area of refuge for folks in wheelchairs and walkers that are right next to the stairwell. By default, we would have them go into the stairwell if it was their apartment that was on fire or if their apartment was filled with smoke. Could the area of refuge be in our attack stairwell? That's what I'm worried about. That's what I'm worried about. The other thing is, I've got buildings, we don't have the landings and the stairwells aren't big enough for all the people in wheelchairs that would be in there. So it's kind of an ambiguous answer, but that's what I'm going to tell you just based on my experience. All right, now, once you've shut off the floor or zone control valve, you're going to move this drain to drain the rest of the water out of the system. That would be the water that is trapped between the open sprinkler head and the zone control valve. We keep harping on don't touch the fire pump, leave the fire pump alone. There's a liability involved in that. Well, there's common sense involved in that too. It's New Year's Eve and you've got a fire pump that's running. True, many electric fire pumps will run for 10 minutes without any demand and shut themselves down. Others, in my jurisdiction, will not. We have to shut the fire pump down. Some of them simply have a stop button. Others, we're going to have to shut the transfer switch. In this order now, transfer switch, main disconnect for the fire pump, and jockey pump switch. Okay, and there's your jockey pump controller. Can we rely on the building's fire pump? Well, hey, I'm looking at that, and it's not looking too healthy to me. I'm looking at a close-up of this building's fire pump, and it looks more like colonoscopy. Looks like my colonoscopy. Looks like my pipes are all corroded. Well, that's the same thing that's going to happen with an old fire suppression system. So do we rely entirely on a building's fire pump? No, we don't. We go in there. Is it running? Is it going to continue to run? Is there water passing out of the packing? If there isn't, it's going to burn that shaft up in short order. Are we going to rely entirely on the building's fire pump? No, that's why we have fire department connections. Oops, I hope we can do a little bit better job than that. Now, is the fire department connection a necessity or a precaution? Depends. How about a dry standpipe? Definitely a necessity. Now, this is at a military base. The problem with a dry standpipe is there could be valves open in the system and you don't know it. Or in this case, valves missing and you don't know it. Or it hasn't been flowed in years, you pressurize it and burst it at a victolic coupling. I walked into this building, it's under construction in my district, and I look at the specification plate of the pump and I'm appalled. 300 gallons a minute at 75 PSI. What in the heck is this? How can this be? I thought a fire pump is designed to flow, depending upon the number of standpipes. If it's a 2-standpipe system, 750 gallons a minute at 100 PSI at the roof. What is this? So I checked with my buddy, Kevin Carrier, and he says, no, this is a manual wet standpipe. Well, basically what it is a manual wet standpipe system shall be a wet standpipe system, so you don't have to worry about open valves, connected to a small water supply for the purposes of maintaining water within the system or sharing a water supply with an automatic sprinkler system, but not having a water supply capable of delivering system demand attached to the system. Now that means it'll supply the sprinklers. It will not supply the hose streams operating off of a standpipe. Now the advantage of this again is you can supply your sprinklers and you don't have the problems with wondering if the valves are open in a dry standpipe system. They are approved when the building is less than 75 feet in height. Okay, it'll have a 2.5-inch inlet for each 250 gallon a minute demand that the system would be placed on, and this is how they test it. It's tested very similar to a regular automatic wet standpipe in the sense that the first 500 gallons a minute should be obtained by flowing from 2 separate outlets on the most remote riser. What are we looking at usually, people? We're usually looking at the roof, okay, roof manifold. The second standpipe would have to flow 250 gallons per minute. In this case, they're using diffusers on the roof. The additional 250 gallon a minute requirement shall be obtained from each additional standpipe to a maximum of 3. Okay, is a FDC a necessity or a precaution here? It's a necessity. If this is a test, and I have to give my brothers in the City of Miami Fire Department a big shout out. They recently did a test of a temporary standpipe system and pumped the roof of an 82-story building, put their engines in series, did everything right. They used key high-pressure hose specifically designed to pump a fire department connection. They did everything right. Lashed the lines down to their discharges of the pump opposite the pump panel, away from the driver's side, lashed them down at the FDC, cordoned off the area, had one pumper connected to a hydrant, pumping into a second pumper. The one pumper raised the pressure, intake pressure to the second pumper to 250 PSI. That pumper raised the pressure to 500 PSI, was enough to get the flow. I believe they flowed one line at the roof, 250 gallons a minute at well over 100 PSI. If there is a pump on these temporary systems, it's just to keep the piping wet to detect any leaks. It's not going to supply an adequate fire stream. Also remember, in your area, you may only require one working standpipe per building when it's under construction. So if you got a building with a huge footprint, that could be one heck of a stretch if you only have one functioning standpipe. And when you're operating in a building that's under construction, understand that you may have iron pipe thread that hasn't had the national standards pipe nipples put in yet. So that's something you should be thinking about. standpipe accessory bag, we carry adapters that would adapt iron pipe thread to national standard fire hose thread. Okay, we're going to come up to a fire department connection. We're coming up with some type of striking tool, double male and double female, spanners, and flashlight if it's at night. Okay, if you had plugs are male caps with chaps with male threads. Take them both out. Why? Because if you only take one out with the intention you'll pump one inlet and then come back and pump a second, invariably that clapper will leak, and you will have a buildup of pressure up against that plug, and that plug will become a missile if you try to take it out. Additionally, if you have multiple inlets, use two that are not right next to each other so you can get some spanners in there. Also, if there are plastic or pot metal caps rather than brass plugs, you may think about replacing those with plugs, because if you have a leaky clapper, it'll blow those caps right off. All right, so here, be a gentleman. If you're on an automatic fire alarm, do not break these frangible caps. Take a moment to unscrew them. Do not use your hands to probe into a fire department connection. In this case, you have an insect nest, you've got broken glass, you've got hypodermic syringes, you've got all nasty manner of horrible things that people tend to put in these types of things. I don't want to get into any detail. Here you've got, looks like a plastic bag or a beer can. You know where that's going, brothers. You know where that's going. It's going right up to the most remote sprinkler head that's flowing, or it's going to the end of your fog nozzle if you are unfortunate enough to have a fog nozzle on the end of your line connected to the standpipe. Let me back up here a second here. All right, how much? I'm going to ask right now at what point we are in the presentation, because I lose my track of time. How are we doing?
57 minutes.
Oh, and I got 90. Oh, we're good.
That's right.
All right.
So.
In fact, I'll probably finish early and just show pictures of my kids and vacation and all that. All right. Let me go to another question here. How will the phenomenon of combustible sighting change our protect and play strategy? Oh, that is a huge. That comes from Christopher Kip. Oh, brother, what did we learn from Grenville Towers? You are spot on, brother. How in the world can we caution people, advise them to stay in their apartments when the fire is scaling up the outside of the building and exposing every apartment in the building? You are absolutely spot on. It requires a total paradigm shift in our philosophy in terms of protect and place. Excellent question there, Christopher Kip from my brother in Columbia. So I'm going to guess Columbia, South Carolina. Okay, let's get back here. Now, invariably, these swivels will be frozen. It's paint, corrosion. There's also a good chance they're going to be missing a gasket. Again, use a flashlight and a spanner, not your hands. Okay, so what can we do? We got a double male, we got a double female. You spin in the double male, and then you utilize the double female, and you got yourself a swivel. You got yourself a swivel. All right. If you don't have the double male and double female, this does work. Rotate the hose counterclockwise a number of times, and then untwist it and tie it into the system. How about this? I know in my area, salt air is not a friend to fire suppression system components that are exposed to the elements. In this case, you can see a screwdriver just went through it. This one was launched at about 120 PSI. I want to thank my friend Mac McGarry for that picture. And we are going to watch a malfunction of a fire department connection run the faulty FDC video. Okay. While we're back, and man, the questions are absolutely phenomenal, and I'm going to wait on the next one from Mike Guilfoyle. Here's the kind of guy I admire. He's a sprinkler fitter, and he's a career firefighter. It doesn't get any better than that. What an asset he would be to that department. All right. So, you can have a malfunction of your fire department connection. And God knows if you are in an urban environment, that brass is ending up in somebody's scrap metal yard or pawn shop. It is not at all uncommon to see that they're missing. I'll give this guy a shout out. He's real nice to us. He lets us use his products at our schools. And this is a solution. You'll see on the right, this is a device that fits in that race, that bearing race, where the swivel used to be, but was stolen by somebody that took it to the scrapyard for some money for pharmaceuticals. Yes, pharmaceuticals. So it's a good solution. It's a good solution. It's a good product. Okay. Now, let's say that we cannot use the FDC. Could we use the first floor outlet as an inlet? The answer is yes and no. The answer is yes if it is not a pressure-reducing valve, and the answer is yes if it is in the same zone as where the fire is, where the outlet is going to be. If it's a pressure-reducing valve, which I'm going to get into in just a moment, it's not going to work. It's going to function as a check valve. I caution you that you're going to flush, of course, but you're going to flush cautiously. If you have a company that is already operating a hose line up on the fire floor in an IDLH environment, if you just wide open flush that first floor outlet with the intention of pumping into it, you'll be stealing their pressure. And I learned that from my dear friend Mike Dugan from the FDNY, and he's absolutely right. To expand on that, don't open that valve until you have pressure in that line going up to the valve. So basically configuring a double male, double female, if you'll notice, that is a conventional hose outlet. And here we're improvising. My department does not have Siamese appliances, so we're improvising a Y with double males and females. Okay, then we get into this guy. Now, this is a pressure-reducing valve. This controls pressure in both static and flow. Now, why can we not pump into this if this is the first floor outlet? Why can't we make this an inlet? Okay, if you will see that the action of that pencil eraser is pushing down on a floating valve, that is in response to a rise of pressure on the discharge side of this valve. So if you were to pump water at pressure into this outlet, the water would go in that little hole in the valve stem and fill the chamber and exert a downward pressure, closing that valve, snapping it shut like it was a check valve. So, you can't use a PRV, and we'll talk more about that, identifying it and their function just in a few minutes. This is a test header. Now, provided you're in the same zone, there may be a problem if it's not in the same zone. And I'm going to be honest, I've never pumped into an FDC or a test header where we had more than one zone. So, there's some things I just have to defer to other people. And if I ever encounter a building like that, I'm going to ask my buddies in the Fire Prevention Bureau or suppression system contractors. Understand what this is here. This is a test header. This is to test the fire pump. It should be tested, I believe, on a yearly basis. In this case, this is a 25, 250, 500, 750-gallon-a-minute pump. Okay? So, we could pump into the test header. Now, when you do that, remember, this is not a wall hydrant. It's a test header. You have to use double males, or females, double females, and then You have to go inside the pump room. You must go inside the pump room and open up a valve in the discharge piping to the test header. Now, before you would do this, of course, you would try to find another fire department connection. Okay? But it's not uncommon in an urban area to have them all screwed up, hit by vehicles, vandalized by thieves. So we went ahead and we put it to pressure. Let's say that we have a failure of the standpipe system. Could you haul hose up? Not very far. This is a test that we did on the roof of an 18-story building. We used Key combat-ready hose because it has a service test pressure of 400 psi. Connected a rope to it so it didn't fly in the breeze. Put tubular webbing around it, connected it to a roof manifold. Got everybody out of the way, and we charged it. Now, this is you live and you learn. And if you're so paralyzed of making a mistake or embarrassing yourself that you never try anything new, then just sit in your recliner and just watch TV all afternoon. Okay, you know what? It failed. Can you see what happened? I choked it off because of the weight, because of the pressure. So what did we do? We rethought it. We put a girth hitch around the highest, most suspended coupling. Now, when you support it, all of the weight of the hose above or below the uppermost suspended coupling is being supported by the rope, not the hose. Now you can have a bend in that hose that comes up, goes over, without a major kink obstructing your flow. Potentially dangerous? You better believe it is. How far could we go? I would love Key to give us some hose, and I'll go to a construction site and 80-story building, and we'll stretch it up the side of the building and see how far we could go. I would love to do that. I know that there's been some tests, but I have no first-hand knowledge. I know the brothers in Clark County, I think they did it 23rd floor with success. In fact, they wrapped the tubular webbing around the coupling itself so it doesn't crush the hose at all. All right, could you use a well opening? Yeah, you could. How about this? Well, yeah, to an extent you could. Just bull the 2.5 or 3-inch line up the stairs, but it's very personnel intensive and time intensive. Okay, let's get into pressure regulating valves, pressure reducing valves. NFPA 14, post-1993, requires a minimum pressure on standpipes to be 100 psi and no greater than 175 psi, no more than 175. So you have a problem. You got yourself a 50-story building, and you can imagine what the pressures would be at the lower floors. You figure you're losing about 6 psi per floor from the base of the standpipe. So you've got some really, really high pressures at the bottom of the standpipe. So in this case, 440 psi. Now, there's one way of controlling this pressure, is zoning it. So in other words, you've got two separate standpipe systems in this building. You know, one begins at the ground and goes up to the 20th floor, and the other goes from the 20th floor to the roof. Right, so there's separate systems, and you would pump to the base of either one of those standpipes. Okay, I don't expect you to be able to read the intricacies of this, but what I'm trying to show you is that in this building you've got a low zone, a mid zone, and a high zone. The low zone pumps are at the ground level. I believe at a mid level they have mid zone pumps, and then you have water tanks at the roof. High zone pumps that actually pump the water back down because the head pressure at the highest floors wouldn't be enough. Would be insufficient. Okay, this is just another diagram. Okay, before 1993, the minimum pressure required was 65 psi, and the maximum pressure was 100 psi. Okay, so that is why a lot of fire departments want to hear nothing of using anything other than 2.5-inch hose because they especially before 1993, they believed that the system pressures were predicated on the use of 2.5-inch hose with an 1.125 or 1.25 tip. It certainly is no place for a fog nozzle that operates at 100 psi. That's for darn sure. Also, that's not even considering that it could be clogged with debris. Now, if the pressure does not exceed, in a pre-1993 building, if the pressure does not exceed on the system side, does not exceed 175 psi, you can use some type of pressure restricting device to bring that pressure down to 100 psi as the standard required pre-1993. So how do we do this? We have a device that restricts its flow, or and this is another one that restricts just its flow. And again, the pressure in the system would have to be less than 175, and this device would bring it down to 100, maximum 100. This is pre-1993. Okay, this is a vane-type device. This is a device that prevents you from opening the valve completely, as this one does to flow only. But in this case, when you have pressures on the system side, the standpipe side, I'm probably not using the proper terminology, the standpipe, the inlet side of the valve, if it exceeds 175, you have to have a valve that controls that pressure and limits it to 175 in both static and flow. In both static and flow. Now, how do we learn about this? Well, we were all clueless, all of us, until the One Meridian Plaza in 1991, and what did we find out? We found out just how pressure sensitive PRVs can be, and I'm not going to get into a long examination of that, but I will say this. We all were clueless. We all were clueless, and it took a tragedy for us to learn, and it just happened that it happened in Philadelphia. It could have happened to any of us. So how do we identify a PRV? Well, one is the large rim. The other is, it'll say reducing valve, pressure reducing valve. By the way, just so that we have a clarification, these guys here are called pressure restricting devices, PRDs. The devices that limit the pressure only in flow are PRDs, pressure restricting devices. Now, that is different than a PRV, pressure reducing valve. Okay, how do we identify it? The large rim, pressure reducing valve. Notice there's no large rim on that, so that's not a dead giveaway all the time. Here's the dead giveaway. Take the cap off, look in there. If you see a threaded valve stem, it's a conventional outlet. Conversely, no threads on a PRV because that valve floats. It is not mechanically connected. It is not actually connected to the threaded valve wheel. It is made to throttle in response to changes in downstream pressure. Hence, that's why you can't pump into it. I think you can see the little hole there at about the 7 o'clock position down low. That's the waterway that fills that chamber that acts upon that valve when the pressure rises to a predetermined level. Okay, this is the effect. You've got 130 on the system side, and there's 130 on the standpipe side, and it's bringing it down to about 70. This is during a pump test, and it was inadequate. Okay, we also have them on sprinkler systems as well. Up above the standpipe outlet, you have a floor control valve. Okay, and this one is for a garbage chute. Now, let me get into Mike's question here. Mike Guilfoyle. As a sprinkler fitter in the Chicago and surrounding area, as well as a career firefighter, I know that the city of Chicago refuses to allow pressure reducers that utilize valve control through throttling the valve. Mike, I'm going to guess we're talking PRVs, okay? I was originally from Chicago, but I have no firsthand knowledge. However, this results in enormous pressures, sometimes as much as 300 pounds, as in the 90-story Aqua building in Chicago. Please address this. This is the reason for PRVs. Yes, you could have tremendous static pressure. When we talk about our standpipe kits, we're going to include an inline valve, or inline gauge, and remember that the inline gauge, the reading on the inline gauge that is attached to the standpipe outlet is meaningless unless you are flowing water through the nozzle. Mike, I understand you could have tremendous pressures on the discharge side of a conventional outlet if they're not using a PRV. I cannot speak directly to the situation in Chicago. Maybe somebody could. But I do know that if you set your, I don't care what pressure you have, if you set your discharge pressure, how far you open the valve wheel based on your flow pressure, looking at the quality of your stream and the reading on your inline gauge. For instance, you got 4 lengths of 2.5-inch hose off with an 1 1/8 tip. You're looking at 80 psi if you're on the floor below. That'll give you your friction loss of 12.5 per 100 feet. That's rounded off to 25. And you got a nozzle pressure of 50, and you're on the floor below. That's 5. So the magic number there is 80, and you'd mark that on your gauge. All right, how are we doing on time?
We got about 12 minutes to go.
We got it. We'll do it. Do rooftop water supplies exist anymore in high-rise building? You bet they do. You bet they do. And they're springing up all over the Miami area. Yes, they do. And they typically have pumps at the roof level. This comes from Mike Downs Community Fire Protection District. You're taking advantage of elevation, but the elevation 10 feet below that elevated tank would only be 4.34 psi. So you got to have pumps that actually pump down from those rooftop tanks. Okay, good question. Can you show a picture of a 5-inch line hooked into an FDC? Lance, you better be very careful with that, my brother. Are you using supply hose, LDH, or are you using attack hose? If you're using supply hose, your maximum operating pressure is 185 psi. Be very careful with that, my friend. Okay? Captain, what size line do you use? 2.5 or 3-inch or LDH? 3-inch. 3-inch, and if you've got super high rises, then you're going to have to look into your high pressure hose. 3-inch, man. It's 3-inch into an FDC. When we look at the pump specifications plate, I see the net pressure and max pressure. I'm making a document for buildings in my zone similar to Clark County. So far, for us to take over supplying the system via the FDC. Which pressure did we need to overcome, the net PSI or the max PSI? The answer is max PSI, which is usually your pressure, your churn pressure, with one big exception, Danny Moran from Fort Lauderdale, you dirty dog. I've known you for years. Danny, you better check the specification plate. It is not. Don't look at one of these small pumps for an automatic manual wet standpipe system. Make sure it is indeed an automatic wet system. And then look for the specification plate for churn pressure, max pressure, or the document of the recent pump test. Okay, we're almost done here, guys and girls. Then I can show you some pictures of my my next vacation here, my last vacation. Okay. All right here. All right. I took this picture at the Palm Beach County Fire Rescue Training Academy. Let me just give you a close-up of it. It's a pump panel. Operate valves daily, lubricate valves, and operate levers weekly. Check primer take. Operate valves daily. Operate valves daily. Okay? This is what my guys do every morning. It's not a pump test. It's a ritual. Now, we don't have freezing weather, so they get that rig out of the hydrant, and they flow every valve on that rig. Check every gauge. Exercise every valve. Conversely, think about a valve that sits on your fire apparatus. The interior components are immersed in water and hasn't been opened in 5 years, 10 years, 15 years. Would you put much faith in it? Hell no, you wouldn't put much faith in it. Look at this, pretty on the outside, corroded all the hell on the inside. Corroded. You see that, the corrosion there? That is a floating valve stem that is designed to rise in response to the downstream fluctuations of pressure. It isn't going anywhere. It's frozen shut. Okay, that's why standpipe suppression systems and sprinkler systems, whether they have PRVs or not, should be tested in accordance with NFPA 25, which is the tests for water-based fire suppression systems. It's fairly easy with the sprinkler systems. You've got the drain and the test valves, and they go right into an express drain riser. Let me just go to this slide right here. Okay. This is a test. We're doing a cap test here. This is yearly on a PRV outlet. And this is the disclaimer from a major manufacturer of PRVs. And it says, quite clearly, proper performance is dependent upon licensed qualified personnel performing regular periodic testing according to the manufacturer's specifications and prevailing governmental and industry standards and codes, and upon following these installation instructions. Failure to do so releases the manufacturer of any liability that it might otherwise have with respect to this device. Such failure could also result in an improperly functioning device. I posed a question to a representative of a major manufacturer of PRVs, and I said, I don't want you to get offended now. I'm playing the devil's advocate here. I burn up in a wind-driven fire, and I can't get sufficient flow because it's determined that the PRV was frozen. I couldn't get adequate flow out of it. And my widow comes to sue you for defective equipment. What's your recourse? He says, well, it's very simple. Very, very simple. Show me the test records. When was the PRV last pressure tested with a cap gauge, and when was it last flowed in accordance with NFPA 25, which requires a pressure cap test once a year and a full flow test every 5 years? Is your jurisdiction doing these tests? That would be 250 PSI at 100 PSI residual pressure. Where are we throwing the water? Hopefully the building has an express drain riser with a female inlet on every other floor where we can flow this. Is your department doing it? I don't know. All right, how much time we got there, Derek?
We got about 4 minutes left.
Okay, good. Good.
Start wrapping it up.
What we're going to do is we are going to wrap it up, and I want to wrap it up with some questions. The purpose of this was not evolutions. It wasn't really to teach you systems, because frankly, I don't know that I'm qualified to teach you systems. My objective is for you folks to reach out to fire suppression system personnel, contractors that turn these wrenches every day, and our fire prevention people. Reach out to them. They are familiar with the systems. We have got to do a better job of narrowing that gap. I've got a question 10. Captain Guston mentioned a formula for calculating pump discharge pressure for FDC high-rise attack. What is that formula? Thank you. Okay, now this is, remember, it's better to know what the demand pressure is. And if you have PRVs, you're going to have to, regardless of where the fire is, you're going to have to pump the demand pressure for that specific zone. I don't care if the fire is on the first floor. Okay, if you have PRVs. If you want just a good way to start, just a rough figure, number of floors times 6 plus 100 or 120 psi. That's the number of floors times 6 plus 100 to 120 psi. Number 17, what is your opinion on when hooking into an FDC 2-inch hose into the 2 inlets or use 1 inlet? Ooh, no, I don't. Fellas, I'm not comfortable using LDH, supplying fire department connections. Guys, I'm in Tampa right now, and I know that there's 4 or 5-story buildings all over Tampa that have a Storts connection, and they're fine with that. Okay, let's see here. Speaking of London high-rise, how does it change our strategy? Well, I know one thing's for sure. We better find an expedient way to cascade water down the outside of a building, either mechanically or manually. Disabling the PIV or PID is possible, but we need to know how. Philadelphia Fire Department had a great awareness. There are field-adjustable PRVs, and there are fireground adjustable PRVs, and then there are ones that are factory set. Our big worry is that a PRV that was designed at the factory, set at the factory to reduce the pressure for the 3rd floor, which would be much higher pressure than the 30th, ends up on the 30th. Nice job, Bill. Who's this guy? Oh, Mike Guilfoyle. Mike Guilfoyle, you're my new buddy. So we are going to start networking, and hopefully, because we all have a lot to learn, and who do we learn from? We learn from ourselves. Derek, any further questions? The last time I did this, I answered them, and I'm not afraid to say, I don't know, I'm not sure, or I got to go check with somebody else. I am not an expert in fire suppression systems, and this short class is just to broach the subject and heighten the awareness. We can't get into the nuts and bolts because we don't have the time, and frankly, I don't think I'm qualified to do it. So, to my brothers and sisters...
answer them later.
Okay, and I will. I will answer every one of those. Brothers and sisters, learn your systems, learn your buildings. High-rise fires and fires in standpipe-equipped buildings are usually not frequent events. You go to a lot of automatic fire alarms, and almost all of them are either malicious pull stations or a pot on the stove. Understand that you can have a serious fire. Okay, we did it.
I know
we did it at a time.
You got so much great stuff to talk about. I know.
All right, brothers and sisters,
I'm getting the hook.
Stay safe, and may God bless you. Goodbye.
And thanks again to Bill Guston. He'll answer your questions later on through answer them later on through email. And on behalf of FDIC and Penwell Corp., I'd like to thank Bill and our sponsor, Key Hose, for today's presentation, Standpipe Operations Part 1, System Orientation. This presentation will be archived within 24 hours and can be accessed from our homepage at fdic.com. A reminder email message will be sent to all registrants, complete with a direct link to the archive. We thank you for joining us today and look forward to serving you with more webcasts in the near future. Have a good day.